They are eruptions so vast, so earth-shattering. They have changed the history of our planet. Climate collapse, toxic turmoil, mass extinction, worse than a killer asteroid or nuclear war. They are Earth's most destructive supervolcanoes. North America. The time was 640,000 years ago, long before humans arrived on the continent. Amid the Rockies, one of nature's great mountain-building projects, vast columns of smoke began to rise high into the atmosphere. And soon a smoky haze wrapped the globe. A thick blanket of ash spread over the western United States. Geologists have traced this event to a depression in the land known as a caldera, in the heart of Yellowstone National Park in Wyoming. Today, we venture to Yellowstone to admire its spectacles of steam and boiling mud. All around, thermal energy is underfoot, like a pressure cooker gathering steam. The heat escapes in an array of smoldering cauldrons, steam vents, and hot springs, like the famous Grand Prismatic. Here, superheated water rises up from deep below ground, then cools and sinks back down in a constant cycle. Geysers are powered by boiling water that moves up through constricted channels in the rocks. When enough pressure builds, steam and water escape in jets that can blast high into the air. Along the Yellowstone River, heat welling up from below softened the underlying rocks to such an extent that water released by rapid melting at the end of the last ice age was able to carve out one of the most spectacular river canyons in the world. Visitors to Yellowstone may never suspect they are atop one of the world's largest active volcanoes. The last time it blew, it sent an estimated 1,000 cubic kilometers of dirt, rocks, ash, dust, and soot into the atmosphere. It's difficult to grasp the sheer scale of that eruption. Compare it to recent experience. In 1980, Mount St. Helens blasted out just 2.79 cubic kilometers of ash, less than 0.3% of what Yellowstone ejected. In 1991, Mount Pinatubo in the Philippines released 10 cubic kilometers of material, along with 20 million tons of sulfur dioxide. A volcano twice that size blew up on the Indonesian island of Krakatoa in 1883. It unleashed the equivalent force of 10,000 Hiroshima bombs and tsunamis that killed 36,000 people. The same year, the Norwegian artist Edvard Munch painted The Scream, with a sunset likely inspired by the effects of smoke from Krakatoa. Clouds like blood and tongues of fire, he wrote, hung above the blue-black fjord in the city. This is Anak Krakatoa, or Child of Krakatoa, an island that has risen in the years since. It is a modest but unruly cone that may be building again toward another big one sometime in the future. The modern standard was set by the eruption of Tambora, 8 times larger than Krakatoa, in 1815. In its aftermath, 1816 became known as the Year Without a Summer. Crops failed and livestock died in much of the northern hemisphere, resulting in the worst famine of the 19th century. The public has long been aware of the hazards of an erupting volcano. Explosions, lava, and debris flows, like the ones dramatized in the movie Dante's Peak.
What is that?
That is a pyroclastic cloud.
The record of recent volcanoes, from Tambora to Pinatubo, has added an additional global hazard. In these images captured by astronauts aboard the space shuttle, you can see the sulfurous haze that covered the Earth in Pinatubo's wake. It blocked enough sunlight to send global temperatures down by about 0.5 degree Celsius. Mount Pinatubo erupted at a time when scientists had begun to use high-powered computers to model the response of Earth's climate to large-scale disruptions. Based on their success modeling the circulation of particles from Pinatubo, one group sought to explore the consequences of another type of eruption. Limited nuclear war. They focused on India and Pakistan, 2 countries that were engaged in a nuclear arms race. The experiment assumed 100 Hiroshima-sized bombs. The intense heat of cities burning up sent over 5 million tons of smoke rising into the stratosphere. With no rain at that altitude to bring them down, soot particles lingered for years. They absorbed far more solar radiation than the brighter sulfuric acid particles emitted by volcanoes. As a result, according to the study, global temperatures dropped by 1.2 degrees Celsius, equivalent to the year without a summer after Tambora. That shortened the next growing season by 10 to 30 days, resulting in widespread crop failures. Finally, in 2 to 3 years, the smoke began to clear, and the climate steadily recovered. But those impacts are dwarfed by what would happen in the wake of a supervolcano. Take the last major Yellowstone eruption, 640,000 years ago. Scientists at the Max Planck Institute in Germany used an ensemble of computer models to study its impact on Earth's climate Their virtual eruption sends up a giant cloud of ash and dust that's taken by high-altitude prevailing winds. In a month's time, the cloud has spread over much of the northern hemisphere. The simulation tracks the bitter consequences. Solar radiation at Earth's surface falls off in an uneven pattern. The darkest point occurs around 18 months after the eruption, with the mid-latitudes of North America and Europe experiencing a steep drop in sunlight. Air temperatures fall too, hitting their lowest point at 18 months. In some places, they fall by an average of 10 degrees Celsius. That leads to the rapid growth of sea ice in the Arctic. More sea ice means that the Earth reflects even more solar energy back into space. With cooler surface temperatures, rainfall levels decline, and oceans and land areas retain more carbon dioxide. These factors all lead to a drop in biological productivity. With food supplies lasting just weeks or days in some regions, human populations would be subject to serious losses. From their steep initial drop, average global temperatures recover gradually, approaching pre-eruption levels only after 2 decades. As powerful as the Yellowstone eruption was, it still does not approach the greatest supervolcanoes in history. This is Toba, a large mountain lake on the Indonesian island of Sumatra. It's the crater left behind by a supereruption 74,000 years ago. What made Toba super is the sheer scale of the eruption. Over 14 terrible days, Toba blasted 2,800 cubic kilometers of material into the air. That's almost 3 times Yellowstone. Its grim aftermath was a global cataclysm, including a global cold spell and persistent drought. One theory holds that Toba brought the human species perilously close to extinction. What causes a catastrophe on this scale? The answer takes us back to the birth of our sun, around 5 billion years ago. It began in a swirl of debris, likely drawn together by shock waves from a stellar explosion. Amid the chaos of the early solar system, gravity drew clumps of rock and dust and gas together. A fiery young planet formed, molten at first. Millions of years passed. Earth's surface gradually cooled, but its interior remained hot. Add to that heat generated deep within the planet by the radioactive decay of uranium, thorium, and potassium. To this day, As more magma enters the reservoir, the pressure increases. That forces magma up to the surface, and a volcano erupts. A supervolcano, like Toba or Yellowstone, begins with a much larger reservoir of magma. A recent study showed that the larger it gets, the more buoyant the magma becomes amid the solid crustal rocks that surround it. Over time, this buoyant reservoir pushes up on the terrain above it. The rock above the magma begins to break. Channels or dikes form to release the rising magma. The land collapses onto the magma, helping to propel it up and out. The volcano does not so much erupt as it explodes,